Hi everyone, I am Abdul, Sittie, Aliah, Jehan, and for today's video, we're gonna tackle activity 4, which is the factors affecting solubility, nature of solute, and solvent. For the objectives, number 1, to observe the particular main purpose of the solubility. Number 2, to know and understand what is solubility and of solvent. Number 3, to understand the factors affecting solubility. So let's define solubility. Solubility is defined as the maximum amount of a substance that will dissolve in a given amount of solvent at a specific temperature. Solvent is a component of a solution that is present in the greatest amount. It is the substance in which the solute is dissolved. Usually a solvent is a liquid. Factors affecting solubility. Temperature, stirring increases the speed of dissolving, and polar. Temperature. Basically, solubility increases with temperature. It is the case for most of the solvents. The situation is though different for gases. With the increase of the temperature, they become less soluble in each other and in water, but more soluble in organic solvents. Stirring increases the speed of dissolving. Stirring doesn't have an effect on solubility of the substance, but everyone knows that if you put sugar in tea, it does not stir, it will not dissolve. Polarity. In most cases, solutes dissolve in solvents that have a similar polarity. Chemists use a popular aphorism to describe this feature of solutes and solvents, like dissolves like. Non-polar solutes do not dissolve in polar solvents and the other way around. In this experiment, we're gonna need 3 containers: cooking oil, alcohol, disinfectant, gasoline, ink, water. Place 5 drops of oil in each container. Add 10 drops of water in the first container. 10 drops of alcohol into the second container. 10 drops of gas into the third container. Shake each container and record your observation. Observation number 1. Oil floats on top of water because it is less thick than water. Oil molecules, on the other hand, are nonpolar and unable to form hydrogen bonds. Water molecules will stick together, and molecules will stick together. 2 separate layers are forming. Observation number 2. Oil and alcohol. The oil sinks to the bottom of the container while the alcohol floats on top. Despite the fact that both water and alcohol are liquids, varying types of alcohol have different densities. Because a drop of alcohol is lighter than a drop of oil of equal size, it flows on top of it. Observation number 3. Oil and gas. Hexane, heptane, and octane are among the nonpolar chemicals found in gasoline. As a result, gasoline dissolves oil effectively. Repeat procedure 1 but replace oil with Zonrox. Make sure the amounts of disinfectant used are almost equal. Add 10 drops of water to the first container, 10 drops of alcohol into the second container, 10 drops of gas into the third container. Shake each container vigorously and record your observation. Observation number 1. Water and Zonrox. Zonrox is a disinfectant that is both cheap and effective when mixed with water. You can make a high, low, or intermediate disinfection by mixing different amounts of bleach with water. Observation number 2. Alcohol and disinfectant. When you mix bleach with alcohol, it dissolves quickly. They have the ability to produce chloroform. Observation number 3. Zonrox and gasoline. If you see, gasoline and bleach do not dissolve properly because bleach with hydrogen peroxide produces oxygen gas forcefully. It has the potential to produce an explosion. Repeat procedure 2 using iodine or ink. Add 10 drops of water to the first container, 10 drops of alcohol into the second container, 10 drops of gas into the third. Shake each container vigorously and record your observation. Observation number 1. Ink and water. Water molecules bump into ink molecules as they move around randomly in a mixture containing ink. prompting them to move randomly as well. There are more collisions with water molecules in areas where there are more ink molecules, which cause the ink molecules to move about. Observation number 2. Alcohol and ink. They dissolve well, but ink dissolves in alcohol, indicating that the ink is soluble in it. The ink should have run out along with the cloth that has alcohol when you poured drops of alcohol to the graphics on the t-shirts. Observation number 3. Alcohol and ink. The ink and gasoline don't mix well together. They are apart from one another. Activity number 5. Factors affecting solubility, pressure. Objectives: to understand the factors affecting solubility and pressure. Factors affecting solubility, pressure. It affects solutes in their gaseous state more than the ones in a solid or liquid state. The solubility property of a gas is said to increase with the increase in partial pressure of the gas. Observation: to enhance the amount of carbon dioxide dissolved in the solution, all carbonated beverages are under pressure. The pressure above the solution drops when the bottle is opened, causing the solution to effervesce and part of the carbon dioxide to escape. Generalization: to a certain extent, the higher the pressure above a liquid, the more gas that can be dissolved in that liquid. The solubility of gases is proportional to their pressure, and as the pressure rises, so does the solubility. A drop in pressure, on the other hand, diminishes solubility.